Okay, we're going to talk about a milliwatt today. So 1 milliwatt, that's 1/1000th of a watt, right? Milli. So most of the time in radios and stuff, you're talking about watts. You're talking about 10 watts, 5 watts, 10 watts, 100 watts, 1,000 watts, and you use something called a watt meter. And there's a watt meter there, and that one's good up to, there's a high range and a low range. So I think that one will go up to 1,000 watts, but certainly does 100 watts. That's what I've used it at. So what about a milliwatt? So that meter is not going to measure a milliwatt. The needle won't move at all. It won't move. So how do you measure a milliwatt? Well, if you have a fancy power meter for, RF and microwave work, those generally work in the milliwatt ranges. So anything above 1 watt, RF engineers will talk about watts. But anything under 1 watt, RF engineers will now talk about dBm, dB milliwatt. So that's dB's reference to 1 milliwatt. So 0 dBm is 1 milliwatt. And then, so most RF power meters will operate around plus 20 dBm down to maybe minus 70 dBm. So somewhere in that range, minus 70 to plus 20. So not very much, right? Less than a watt. Everything is less than a watt, and usually really tiny things. So you're talking about building, oscillators and amplifiers and circuits and stuff. You're talking very, very small little amounts of power. So let's talk about why you might care. So you might have something like this. You might have a spectrum analyzer, a tiny SA, and you want to keep things, around 0 dBm and less, so less than a milliwatt. You don't want to put much more than a milliwatt into these guys. You'll destroy the first section that goes into the spectrum analyzer. There's an attenuator, and you'll either destroy the attenuator or it'll go through and it'll destroy something else. So it might blow up the mixer or something. Anyway, you put more than a milliwatt into these guys and you can destroy them. All right. So in fact, people are, and they're starting to put stickers on them now. So if you buy a brand new one of these, I believe it has a sticker on here saying, danger, danger, don't put more than, I think they say plus 10 dBm. But my rule of thumb is always keep it below a milliwatt. I think that's a good rule of thumb. All right. So even if you have a fancy spectrum analyzer, if you read under the connector, so I have a big fat connector on here. Let me get rid of that so we can read it. So under there in danger orange writing, it says plus 30 dBm. Plus 30 dBm. Now that's quite a bit, plus 30 dBm. So this is pretty rare, I think, plus 30 dBm. Most spectrum analyzers, I believe, will probably be in the plus 20 range, something like that. But anyway, again, if you put 1 watt, well, maybe not 1 watt, it might not blow this one up, but, if you hook it up to your 100 watt transmitter, yeah, you will definitely destroy this. And the spectrum analyzer itself is usually measuring things very, very small. So a spectrum analyzer can measure things down to minus 120 dBm. So a spectrum analyzer like this can go very, very, very low. So really, really small little signals we're talking about, okay? So we want to be able to measure a milliwatt, or at least understand it. So most people will not be able to do that. So I'm going to show you a couple ways to measure milliwatts with maybe equipment that you already have. But first of all, let's take a look at equipment that was specifically designed to do that. Okay, so this is a power meter. This power meter is good from 10 megahertz to, let's see, it has to do with the sensor. So this sensor is good from 1 megahertz to 20 gigahertz. So 1 megahertz to 20 gigahertz. And this one is only rated up to plus 23 dBm. It says do not exceed plus 23 dBm. And really you should be keeping this down around plus 10 dBm maximum, definitely maximum. So we've just calibrated this. There's a calibration procedure, but we've just calibrated this. So let's go measure something, okay? This has an N-type connector on the front, so I'm going to put an adapter on it. All right. And I'm going to put an adapter so I can have B and C. I can input things with B and C. So let me get a signal here to measure. Okay. So I'm going to, is this on camera? I'm going to connect the signal source up to the watt meter. And you don't even call these watt meters because you're not in the watts domain. These are power meters. And so let me turn on a signal. I'm going to enter a 1 megahertz signal, and I'm going to set the amplitude to 0 dBm. Enter number 0 dBm. All right. And the watt meter, power meter says 0.07 dBm. So that's quite good. That's pretty much what we would expect. Now this particular generator that I'm using can go up to 15 megahertz. So here's 5 megahertz. There we go. It's 0.01 dBm. Here's 10 megahertz. Exactly 0 dBm. And here is 15 megahertz and 0.01 dBm. So I've showed you that particular box is very, very accurate outputting watts, okay? And we're measuring dBm. You can actually hit the watt button here and it'll say 1 milliwatt, okay? So a lot of things you can either express it in watts or in dBms. Okay, so 0 dBm is 1 milliwatt. All right, so let's go look at the instrument that I was showing. Or that I was using. Okay, I've showed this before. This is my arbitrary waveform generator, and it can go from kilohertz or hertz all the way up to 15 megahertz. So I have it here, 15 megahertz. But the nice thing about this one, for this particular video, is that a lot of function generators only output volts. You can say I want to output 1 volt. This one can output things in volts peak to peak, volts RMS, and in dBm. So I can say amplitude 0 dBm. Or I could say, so many millivolts, or so many volts, or so many volts peak to peak, so many volts RMS. So all different sorts of measurements you can make. Now, because this is fully synthesized, it's all very accurate because they're controlling the voltages very accurately into these things. And the output is always assumed that it's loading into 50 ohms. Okay, so this 0 dBm should be going into 50 ohms. Now, when we have it hooked up to the power meter, okay, this is the other end of the cable. When we have it hooked up to the power meter, the power sensor itself is a 50 ohm load. And that's why you don't want to exceed, it only has a certain amount of, you'll either blow up the load or you'll blow up the diodes. And most of the time, you'll blow up the detector diodes. Anyway, the point that I wanted to make, though, is this assumes the mathematics that says 0 dBm here is assuming you're putting this into 50 ohms. It's able to deliver 0 dBm into 50 ohms, okay? And that will become evident here quite soon. So let's do another thing. We're going to keep it at 0 dBm. I'm going to change the frequency to 100 kilohertz. 100 kilohertz. Okay, so it's 100 kilohertz, but we're still outputting 0 dBm, okay? All right. So let's take a look at another piece of equipment that we can use to measure dBm. And I have it right here. Let's turn it on. So this is a Keithley 2015. And let's do both of them. Sure, why not? Let's do both of them. Okay, and up here, I have an HP 34401. So they're just 6.5 digit voltmeters, okay? Now, see, whoa, wait a minute, they're voltmeters. How can they measure dBm? That's a power measurement. Well, they can. So each one of these, this one has a dBm button here, and this one has a dBm button over here, okay? So let's do this one first because it's a little easier to do. So we're going to input the signal into here, all right? And we are going to measure certain things, all right? and we are going to measure AC volts, not DC volts. It's an AC volt measurement. So we're measuring AC volts, okay? And the filtering's on and stuff, but it's measuring a certain voltage, okay? And we can measure voltage, and we can measure dBm, all right? Now, let's, before we go any further, let me show you on paper something that you need to know before you can make measurements using these voltmeters. Okay, now I mentioned that if you have a signal source here, and you output from the signal source, and you're going to go and measure the voltage here, and you're going to measure dBm, first of all, there is a source impedance. So there's a 50 ohm impedance of this generator. So this would be the front panel of the generator. This would be the connector on the front panel, okay? It has 50 ohms on the input. And it says we're going to expect the load to be 50 ohms, and then we will guarantee 0 dBm at this point. Now, if you redraw this a bit, okay, if you redraw it a bit, you would have a generator, and it would come out, and it would have its 50 ohm load, its internal 50 ohm, that's that one, and then you're loading a 50 ohm, and you're measuring here. And this one is 50, and this one is 50. So it's going to be 1/2 of the voltage here. So when they design this box, okay, they do the mathematics such that they know this is going to happen. So they will output double the voltage that is needed here. Okay, does that make sense? So if you ask it to do 1 volt peak to peak, 0 dBm, it's gonna force enough voltage to have that true here after this division by 2. So when we have this thing hooked up to the voltmeter is high impedance. It's like 10 to the 12th ohms. It's high impedance, but we need to have it 50 ohms, and so we're going to have to put a 50 ohm load in there. So we're going to have to use one of these. This is a load resistor. So this is just a connector. It's just a connector to connector, and then inside is a resistor, and that resistor is 50 ohms. So that's all that's inside this thing, right? So let's put this up on the 2 voltmeters. Okay, so we had 0.44 volts, and I'm going to put in this load resistor, and now we have 0.22, half, right? So, all right. So we've told it to do 0 dBm, and we want to measure 0 dBm here. So we'll do the dBm, which is right here. You do shift dBm. Now the first thing it asks you is, well, dBm reference to what load? And right now it's defaulting to a 75 ohm resistor, okay? So we need to tell it, no, we don't have a 75 ohm resistor, we have a 50 ohm resistor. So you tell it 50 ohms, and this is just for the mathematics, okay? And we hit enter, and now we're measuring 0.04 dBm, okay? Perfect. That's sort of what we were measuring over on the power meter. So now we can measure dBm here, okay? Now if we want to go up here to this one, we can go up to this one. We can measure AC volts. We're getting 0.22 again. And we can go to dBm. We can go dBm, and it's measuring 0.05 dBm. Okay, so it's very, very good too. But you do have to tell this box that you're operating at 50 ohms, and you do that in the menu system. You go Shift, Menu, you go to Math menu, you come down, and then you go over to dBm, reference resistance, and you go down, and you have to set 50 ohms here, okay? And you could put this at 600 ohms, or whatever ohms that your system is operating at. dBms will be referenced to whatever load resistance you're talking about. But in radio land, it's always 50 ohms, okay? So we need to set this. We need to set this to 50 ohms, and then we're good to go, okay? All right. So anyway, oops, I just set it to the wrong ohmage. So you have a choice here. Let's go back down to 50. and then we'll hit, where's enter? Here, there we hit enter and we're done. Okay, so that's how you measure dBm. So I've just showed you how to measure dBm with a voltmeter. Now, there's going to be a trick, okay? Not a trick, but a trap, okay? A trap. So I'm going to change the frequency. So can I get everything here in camera? Let me zoom out a bit. There we go. That's good. Okay, so we're operating at 100 kilohertz right now. Now, if we start going up, you see that the dBm is no longer valid, okay? I don't know what the spec is on this instrument. It seems like around 400 kilohertz, it's okay, and then above 400 kilohertz, it starts to go bad. And if we keep going up to, 4.5 megahertz, this box can't do that. This box cannot do fast stuff. It can only do slow stuff, okay? So now we have a limitation. So that basically makes your voltmeter useless for any type of RF application. And both of these boxes are the same. So we have to find some way of getting higher frequencies, okay? So we need a voltmeter. That's all it is. It's voltmeter plus some math, and I'll show you what the math is. So voltmeter plus some math. So we need a faster voltmeter. So do you have a faster voltmeter? Well, some people have oscilloscopes. Okay, so once again, if you're going to use an oscilloscope, you have to make sure you still have your 50 ohm load on. You need that 50 ohms. And we're going to put that into the oscilloscope. And we are going to measure the volts. There we go. And there we go. We've got our signal. We're at 400 kilohertz right now. Okay, so we have 400 kilohertz. Okay? And so we need to measure some type of voltage and then do some math. Okay? All right. So let's go ahead and do the measurement of voltage first, and then I'll show you the math. Okay? So on a Rigel scope, or a lot of scope these days, you can, instead of trying to measure how many divisions there are and stuff, that's not too accurate. There's actually measurements on digital oscilloscopes. So I can hit the measurement button here, and I can just hit measure all. Okay? So there we go. So measure all gives us all kinds of things here, and I know that's too small to read. But I'm going to read you the important stuff, okay? And I'm going to write down two numbers, all right? I'm going to write down volts peak to peak, and it's measuring 6.36. Now that doesn't sound right to me. 6 volts doesn't sound right to me. So there's a trap. Okay, the trap is if we go to channel 1 and we look at the probe is set to 10x. That assumes that whatever's coming in has been divided by 10. Well, it's not. We're going in direct with 50 ohms, so we have to set this to 1. Okay, so we have to set the incoming to 1x. Okay, and then we can use these measurements. Okay, so it says 632 millivolts. Okay, so 632 millivolts. So that's the peak-to-peak voltage. And I'm also interested in the RMS voltage. So that's 224. 224 millivolts RMS. Okay, so one of them is peak-to-peak, and the other one's RMS, root mean square. Okay, and we're going to need those two numbers. All right, so let's do some math. Everybody loves math, right? All right, how do we measure power with a voltmeter? All right, so we have a 50 ohm resistor, okay, and we have a voltage across that 50 ohm resistor, okay. Power equals volts times current, okay. Volts times current is power. So volts times current times amps is watts. This will give you watts. All right. Now, we know that volts equals current times resistance, okay? So current equals volts divided by resistance, okay? And if we substitute this I back into this formula, we find out that power is equal to V squared over R, okay? And we know that R is 50, so V squared. So whatever V squared, we divide that by 50, and that will tell us how many watts we have, okay? All right. Now, the trick is, in a sine wave, we are interested in the power, which is actually an integration. It's actually, there's power under the curve, so you need to do, the amount of power is not peak to peak. The amount of power is some other thing, and that's where RMS comes in. So volts RMS. Okay? So in this equation, we're going to use volts RMS. So what did we measure? We measured 224 volts RMS. So 0.224 squared divided by 50 equals, get out our calculator, 0.224 times 50 divided is 1.003 milliwatts. Okay? So there you go. We measured power using our oscilloscope, using the RMS, volts RMS. So this is we're going to use this formula up here, and we're going to use the RMS value. Okay? Now, if you don't have RMS and you have peak to peak, okay, you can convert it. All right? So we have 632 volts peak to peak. So how do we convert that to RMS? Well, RMS is only on one half. RMS is 63% of one hump. Okay, so first we need to divide this by 2. Okay? And then we need to multiply that by 1 over the square root of 2. Okay? Or 0.707. Okay? So if you take square root of 2 and you take 1 over, all right, this is also 0.707. Okay? So let's take our 632. We're going to divide that by 2. All right? And then we're going to multiply it by 0.707. And it gives us 0.223 volts. Okay? 223. Actually, it's 223.4. But anyway, that's how you convert it. So if you have only peak to peak, you take half of it, and then you divide that by square root of 2 or multiply it by 0.707, okay? And so then you can get this number, you can plug it into the formula. So now you have a voltmeter that can go higher in frequency. So how high in frequency can your voltmeter go? Well, this oscilloscope is good for 100 megahertz. Does that mean that I can use it at 100 megahertz? No. Why not? It says 100 megahertz. Why can't I use it? That's when the instrument starts to roll off. And so there's some point where the voltage is right, and then it starts to drop down. And I think if it's half of the voltage, that's where it's 100 megahertz. So you would only be getting half as much at 100 megahertz that you would at 100 kilohertz. So you have to be very, very careful using the oscilloscope. But the oscilloscope probably is good to higher things. Now remember, our generator could go to 15 megahertz. So let's do that. Frequency, 15 megahertz. But these guys didn't work, right? The voltmeters couldn't do 15 megahertz. But I think my oscilloscope can. Okay? So let's go back to the oscilloscope, and let's read the volts RMS, and it is 0.219, okay? So let's do the math. Everybody loves math. It's 0.219 squared divided by 50 equals 0.959 milliwatts. Okay, so you see that we're getting an error, okay? It's not exactly 1 where it was at a really low frequency. It is starting to drop off. Even at 15 megahertz, it's starting to drop off just a little bit. And so this voltmeter is not going to be totally accurate at, it's probably not going to be very good at 50 megahertz. But maybe up to 20 megahertz, it's still, this is still within, 4%, right? Still okay. But it's certainly not a power meter. It's certainly not a calibrated power meter. But this is the way you would do it. Okay. So if you don't have a power meter, you can measure the voltage, you can do the math, and you can figure out how many milliwatts you have, and it should never be more than 0.224 milliwatts, right? Millivolts, 0.224 volts. And 224 millivolts, 0.22, so a quarter of a volt. If you ever have more than a quarter of a volt on a 50 ohm resistor, that's more than 0 dBm, right? So that's kind of a rule of thumb. So you'd think, oh my God, that's hardly nothing, right? You know, when we take a look at maybe a 555 timer, you know, making some kind of square wave or something, and it's maybe operating from 0 to 9 volts, yikes! This thing can output lots and lots and lots of milliwatts, enough to blow up your tiny SA, right? So be very, 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 very careful. It doesn't take much to get 0 dBm. It really doesn't.